First, an apology. My description of this talk include a lot of topics that won't actually be in this talk. I was going to talk broadly about text layout, and that turned out to be about an hour and a half. And so I decided to trim it down to just one part of text layout, characters, fonts, and glyphs, and that talk was 45 minutes. So I've refocused, and I think this is going to fit. I'm going to talk about just one part of Unicode. Humans like to write things down, and over the last several thousand years, we've developed a wide variety of ways to do that. And then over the last century or so, we started building computers. And computers work with numbers, which does not actually line up that well with how humans write things down. For decades, we have developed numerous systems for encoding human writing into numbers so that computers can work with them. In the 1980s and early 90s, Unicode was developed to unify all these systems so that there would be one single consistent way to encode all of the world's writing systems, including the ability to include multiple writing systems in the same document, which was something that really you couldn't do before. It includes rules for comparing and sorting and text direction, composing and decomposing characters, on and on and on. Unicode has made it practical for us as developers to write software that supports all of the native writing systems of the whole world. But that, of course, is not the most important thing that Unicode has given us. No. The most important thing that Unicode has made possible is emoji. Okay, that's definitely not true, but it often kind of feels like it. I mean, for years, I have been teaching people about bidirectional text and composing characters and normalized forms and why you can't subscript strings by an integer in Swift and why that's actually a good thing. And the most common response I see is, look, I don't care about all these fancy writing systems. I just need English. And so I ask them, well, and emoji? And they said, well, yeah, of course, emoji. I mean, English and emoji. In my experience, Emoji is the most complex writing system in the world. It is filled to the brim with weird grammar, special cases, continual churn every year. It requires its own complex keyboard. If your code can support Emoji, you generally will get Chinese for free. And really most other left-to-right writing systems as well. So let's talk about Unicode. The kind of fundamental thing in Unicode is called the code point. And it's kind of the most basic unit of text in a computer encoding system. Ultimately, computers work with numbers, so we have to have a way to turn letters and symbols and punctuation and all those kind of things into numbers. And code points are how we do that. In Unicode, code points map a unique number to each language thingy for every human writing system. Now, what do I mean by language thingy? It's kind of complicated. According to Unicode, code points map to abstract characters. What does that mean? Okay. The intention is that an abstract character is a fundamental unit of written language that's independent of actually how it's drawn. Everyone here should be familiar with the Latin alphabet, and we're kind of a Latin using culture. And so when I show you this glyph on the screen, you probably recognize it as a lowercase x with an accent, even though that's not a letter in any language I've ever heard of. But that tells us the fact that we can share that I can say lowercase x with an accent, and you can kind of picture what that means, suggests that among Latin using cultures, lowercase x and with an accent are kind of abstract characters. They're concepts that can be glued together and have meaning, independent of the precise way that the X is drawn or the precise way that that accent is drawn. Now, Unicode is wildly inconsistent about exactly how this idea is applied, and really there's no universally consistent way you could apply it. Unicode is the way it is for lots of reasons. Lots of them are backward compatibility with older systems. There's global politics, there are mistakes, and frankly, human writing systems are just really weird and messy, and anything that tries to encode them is going to be weird and messy, because that's how we are as humans. But the idea is that there are these abstract pieces of human writing, independent of exactly how they're drawn, that each code point represents. Now, emoji is no different than this. Emoji have code points. They have a long history that make their code points inconsistent and messy and confusing. And a lot of emoji predates Unicode and have naming and syntax and usages that come from those older systems. Okay, so for example, let's start with a really basic thing. You want to show a red heart. It seems simple. Probably the most common color for hearts to be. So you're going to search the official list of all the emoji for a red heart through Unicode, and you're not going to find one. There's nothing marked red heart. There's blue, white, yellow, beating, green, with a ribbon, growing, broken, sparkling, black, heavy black. There's even this rotated heavy black heart bullet. It's my favorite. But where is red? Seems strange. Well, okay. So part of it is understanding what the vocabulary means. So many emoji come from old Japanese systems and they ran on like flip phones and they didn't have color screens. So when they say white and black, they don't mean the colors specifically. They mean outlined and filled in. And they use the word heavy a lot of times to kind of mean bold or, thick. And so this character, this is heavy black heart. And it's not because it's the color black, it's because it's filled in and also it's kind of squashed and wider than the other main heart symbol, which is called black heart suit. Now, some Unicode characters, then, especially older ones, can be followed by this variation selector. And the point of variation selectors is one of the biggest uses is to distinguish between Chinese-based characters that were unified into Unicode, and that you need a way to say which one you mean when they go back to their original encoding systems where they were distinct characters. Of course, nobody cares about that. The only reason we use the variation selectors is for emoji, because every Unicode feature is eventually for emoji. The two variation selectors, there's 16 variation selectors, and I believe actually only five of them are ever actually used. But the only ones that matter for emoji purposes are 15 and 16. 15 means a text version of a character, which is often the default for emoji-like things. And 16 is the emoji version of a character. So when I look at heavy black heart in its text mode, that's what it looks like. What you see on the screen, it looks like text. And then when I put it into emoji mode by giving a variation selector number 16, then it looks like an emoji. It has color and things like that. And that's the red heart we're all used to. One of the things that's kind of different is emojis kind of sit in the square, much like Chinese characters, that they kind of hang uniformly in their square, whereas text things tend to ride on a baseline, so they line up like words. Let's see this in Swift. Now, Swift is wonderful in terms of you can just take Unicode characters and just paste them in, and it handles them right out of the box. So I found this little red heart, but I don't understand how to actually make it. So I'm going to paste it into my Swift playground, and I'm going to convert it into Unicode scalars. That's what Swift calls a Unicode code point. Swift actually has uses the word code point to mean something slightly different. But they call them Unicode scalars, and we want to convert those to hex. And then once I have the hex, I can reconstruct it using this \u Unicode character to tell me with curly braces. The thing is, I see this FEOF. What's that? I don't know. So I'm going to look it up on my favorite site, which is fileformat.info. I actually have a little Alfred shortcut that'll search file format for me. And that's the place they'll tell me, hey, this is variation selector number 16. Now, if you're dealing with emoji specifically, I do prefer Emojipedia. It is much more in-depth on emoji issues, but it only handles emoji. So I like file format for other things. Now, this idea of combining things like I did with the version selector, that's very common throughout Unicode, all over the place. Probably the most common example in Latin and English in particular is when we import words from French and we have these accented E's and we wind up with a word like resume. There are two ways in Unicode to express that final E. For somewhat historical reasons, there is a dedicated character for it, E9, which is Latin small letter E with acute. But it can also equally and legitimately be encoded as Latin small letter E followed by combining acute accent. And these are completely legitimate encodings, both of them. Well, that kind of creates a problem, right? I mean, what if I want to search for this string? There's two different ways it could be encoded. And in fact, I mean, if there's more accents or more combining characters, things could get very, very confusing, very hard to search for string equality. Now, in Unicode, there are standardized ways of dealing with this. They're called composing, they're called normalization forms. You can force everything to be composed, or you can force everything to be decomposed. And then there's standardized ways that everything gets ordered. But luckily, for the most part, you don't have to worry about that. Swift is going to handle it for you. And so you wind up with something like this. I can have the letter E, and I can have an acute, and I can glue them together. And I can also have just E with acute. And Swift knows they're equal. So no problems. Works just like you think it would work. Except when it doesn't, because if you don't remember that strings are about characters, then the characters don't necessarily compose the way you think intuitively. You can wind up with cases where 1 equals 1, or 1 plus 1 equals 1. So I take a string, and when I combine a E with an acute, the string length is still 1, because there's still only one character, because Swift thinks of that as one composed character. That means also, if you start doing manipulation, it can be quite dangerous. If you start appending things and then like I append an acute and then I remove the acute, that's not a round trippable operation. So you have to be very careful about these, and especially if you're dealing with like network traffic and you're dealing with data in chunks. Things may not always work correctly if you start splitting things in half. If you start getting half of a character. Now, emoji are also characters, and so you can apply diacritics and accents and whatever's to them just like it. But it doesn't necessarily work very well. While emoji are absolutely standard Unicode characters, they are not standard font glyphs. Normal characters are stored as vector graphics in a font. And there's various metrics that let the text layout system know how to place combining marks correctly at the right height, or at least reasonably. And so even though X with an umlaut is not a character in any language I'm familiar with, and certainly is not part of this font, the font doesn't have it built in, it's able to figure out for both capital and lowercase X where to put the umlaut. But for girl, it does not. It does not know how to do it because emojis are stored as PNGs at various resolutions directly in the font. And the text system just doesn't know what to do. So they get kind of placed randomly. And then again, how often you want to do that? Now, as long as we're doing text combining, we should always take a little side trip into Zalgo. It's one of the best ways to misuse and abuse combining characters. If you've ever seen this kind of weird corrupted text, it's just using Unicode combining characters. So it's not that hard to do, and it's kind of fun, a little educational. So there are a lot of possible combining characters in Unicode, but there luckily is a big block at 0300 through 036F that are all of the ones in that area are combining characters, and they're ones that are highly supported, and they are ones that tend to work well together. So this code just goes down each character, picks between 0 and 15 random things to insert, and boom, you get Zalgo text. Now that's fun, but what if we wanted to de-Zalgo the text? We wanted to remove all the combining characters. Now, of course, because we know how we built this, we built it with the specific character range. We could do that, but we could also go to Swift and ask it for information about every code point. In Swift, a string is made up of characters, and a character is made up of code points, not just one, but possibly multiple, or Unicode scalars, as Swift calls them. Each Unicode scalar, each code point, has a lot of information about what that thing represents. So we can go check its properties. You'll see the scalar.properties is grapheme base, and that says this is kind of a thing I'm going to put things on, as opposed to is grapheme extend, which says this is a combining character. You can check all kinds of things with this. You can check if it's a letter or a number or an emoji. You can see if it's like a sentence terminator. You can even, one of my favorites is you can find the numeric value, quote, numeric value. So there is a Unicode character for 1/5, 1 divided by 5, as a fraction, 1/5. Well, and if you ask it, what's your numeric value, it will tell you 0.2. And so you can get that kind of information. You can also get, 4 in a circle has a numeric value of 4. So that can sometimes be interesting, at least. Most of the time, you probably don't want to be going all the way down to the Unicode scalars. You want to be working maybe up at the character level. But for things like this, it's useful. Now, emoji have their own system of combining to form single characters. I've already shown how variation selectors work, right? These VS things, but there are lots more. So for example, we could put a box around numbers. We can take a number and just add what's called keycap, and that's going to put it in a little rounded box for us. Now we can then attach variation 16, and when we do that, we get the emoji style. And you'll notice, if you look at how they line up, the emoji is a little bit higher, and that's because the one is actually sitting on its baseline. It's meant to kind of sit around with text, whereas the one in emoji style is meant to be to sit nicely with other emoji. We have flags. Flags are composed of 2 regional letters. Now, these are not normal letters. This is not the letter U or the letter S. This is the regional, regional letter U. And they're code points specifically for just this purpose, for building up flags. And they match the ISO region code. So US is the United States and DE is Germany. There are a couple of the spec would like to make it very, very clear that it is not a statement, that the existence of a region is not a statement about whether or not something is a country. It says flat out some are territories because some are disputed territories, and the ISO committee would really like to stay out of global politics about it. That, of course, is impossible, but bless their hearts, they try. Essentially, they come right out and go, yes, we're going to say things that maybe some countries don't like, but if it's in the standard, we're going to make a emoji for it. There are 2 macro regions, the UN and the EU, and that's it. But they just act like regular regions, so it's not that big a deal. Or you don't have to think about it very much, and they have their own flags. And if the letters don't form a known region, like in this case, I have an example, NN, then they get displayed in these little dash boxes. Now, sometimes people have gone in and they use those little dash boxes to, because they want the little dash box effect, right? They're actually trying to do that. But of course, that's tricky because it's possible that it might be an identifier, and then boom, you get a flag and you didn't mean to. Now, I would never tell you to abuse characters for things they weren't intended for, but the region characters are for regions, and that's what they're for. They're not for making little dotted boxes around things. But it happens to be true that if you put a 0 with space, this character 200B, between them, then that is a general tool for keeping things from combining that you would like not to combine. So do with that as you will. Now, for regional subdivisions like states in the United States, there's a completely different system, which is tags. Now, tags are actually a general purpose tool for modifying emoji. They happen to only be used, however, for regional subdivisions. You start with an emoji, in this case, the black flag. It must be black. And then you spell out the tag using the tag letters. Again, these are not normal letters. They're specifically for tags. And you terminate the string with a tag cancel character. For regional subdivisions, the tags are all lowercase tag letters, and they start with the region identifier followed by a subregion identifier. So, so in the United States, the state of California's flag would be USCA for, US and then CA. USCA cancel. But that actually won't work on most platforms today. The current recommendation, that is what it will be, or that is what the character would be, but on almost all platforms are following the current recommendation. And the current recommendation only has one set of emoji tag sequences, which is for Great Britain, England, Scotland, and Wales. That's it. I do kind of expect the recommendation to expand to include more regions, particularly the states in the United States, but we'll see. Now, you'll also notice the tag letters are invisible. They don't They're not like they're not like the region letters that have little boxes or have a visibleness to them. So if the tag is unrecognized, it'll generally just show a black flag, which is kind of awkward in my opinion. No, the recommendation suggests that it should add a little question mark or something to make it clear that the tag was not understood, but Apple doesn't do that. And of course, no discussion of flags would be complete without the pirate flag, the rainbow flag. And this year, the recommendation added the transgender flag. Apple has not yet, they don't support it quite yet. So I expect that coming soon. Now, note that the white and black flags here are in Unicode. They're actually called waving white flag and waving black flag, which should not be confused with white flag, which is 2690, and black flag, which is 2691, which will not work for these uses. And unfortunately, if you use the show emoji and symbols pane in your Mac and you search for black flag, you will get the wrong one. And other problem is, if you read the spec, it actually says black flag. It does not say waving black flag. Why? So emoji are usually described in terms of the Common Language Data Repository, the CLDR, short names, which are generally written in lowercase and rather than like the all caps of Unicode names. The Unicode names are unique, immutable identifiers, and sometimes they can be very, very long, but they are never allowed to change. Once they are set, they are set, even if there's a mistake. The CLDR short names are not promised to be unique. They can change over time. They can be localized, and they are. Most of the time, it's not a big deal. It's pretty obvious which character is meant, but not always. And sometimes it's a little ambiguous, like this case where black flag versus waving black flag. Okay, let's talk about people. A lot of emoji rules revolve around people, which is understandable since people are why we have emoji. Most human emoji accept a skin tone modifier. So, for example, woman followed by emoji modifier Fitzpatrick type 5 will come up in this way. The Fitzpatrick modifiers are rendered as tonal squares when they stand alone, unlike the variation selectors, which are invisible when it's not modifying anything. So if you can see in the code, let tone equals, those are the modifiers themselves. What's interesting is in code that is true. They're just sitting there by themselves. When I pasted them into Keynote, they attach themselves to the quotation mark, and they become a single character. So it is in fact a skin tone attached to a quotation mark because skin tone can attach to anything. It just doesn't necessarily modify it. All of this is a bit of forward and backward compatibility features. When you apply skin tone to an emoji that the rendering doesn't know how to support skin tone for, like a quotation mark, or for literally anything, it renders it separately. It renders the thing and then renders the modifier. So a good example would be the family emoji. You can't put a skin tone modifier on a family emoji. I'll talk about why in a little bit, and they might someday, but today they can't. And so this is how they render. They render with the family emoji, which is kind of this, and then a skin tone emoji. Now, this is still actually technically one character. If you had this in your editor and you hit the backspace key, both blocks would be deleted together. And if you try to select them, they select together. It is one character. And you can see I have the Swift. It counts it as one character, even though it's very wide. This is really kind of about forward compatibility. And the idea is that your device, the person who sent it may have had a device that did know how to combine these, and the person sent it, and we don't want to lose that information when we send it to you. And maybe your device in the future will be able to understand it. So in the meantime, we just attach it. Now, also, most human emoji accept a gender modifier, which in Unicode means exactly female sign or male sign. That is it. They don't quite work the same way as skin tone modifiers. To act as a modifier, they need to be part of a zero with joiner sequence. In fact, I want to say the skin tone modifiers are the only ones that are not zero with joiners, that they just, you just do a thing and then put the modifier. Everything else typically has this extra character. A zero with joiner is a thing that says these two code points should go together, even though they normally wouldn't. It's mostly used in index scripts, which are writing. I actually haven't studied them enough to be able to explain exactly why, but they, like all other features, they have been co-opted into being used for emoji. There, so these kind of sequences are incredibly common. Notice here how it works. The skin tone modifier attaches to the person thing, which is in this case the runner is considered the person thing, and then there's a zero with joiner, and then it is modified with a female sign. You'll also notice if you look kind of closely that the base runner emoji is not the same as the male runner emoji. And the intention here is that without a modifier, most emoji are supposed to be gender neutral. There are a few exceptions still, but there has been in each release of Unicode over the last few years, they keep kind of reducing that, and they're trying to make the base form more gender neutral. Now, professions work the other way. The person who comes first, then the noun that describes the profession. So, for example, an astronaut is an adult rocket. In case you're curious, children don't have professions. There's no baby rocket. I'm sorry. Unicode 11 added hair. There are just four kinds of red, curly, bald, and white, and they only apply to adults, men, and women. Children and babies have no hair. But as you can see, the number of glyphs required grows very fast as we add these modifiers. There is a separate PNG in the font file, sometimes at several resolutions, and they're not constructed by the text layout system, right? It's not like the text layout system goes, oh, I'm supposed to change the color of this. They are literally separate PNGs for every single one of them. So the size of the emojis have been growing very, very quickly. There are currently 3,165 glyphs in Apple's emoji font, each at these 9 different resolutions. There are over 27,000 PNGs in the emoji font, which is why Apple's emoji font is twice as large as the mean Chinese font, which has 48,000 glyphs in it. And it's over 1,000 times larger than, say, a font like San Francisco. And this really is not scalable. We can't go as far as we want. The Unicode committee knows this. People want to express themselves as their full selves, and our writing systems need to empower that. But having every vendor develop its own set of glyphs for every possible combinations of human features is getting in the way of that. We're unable to fulfill all of that promise. So despite some rather amazing work that has gone on into it so far, the committee is really pushing vendors to agree on some kind of way to send around just images directly and stop creating more and more and more Unicode code points. That said, emojis are getting some new features, and that's going to add even more combinations. These don't actually work today in Apple platforms. Hopefully someday, or someday soon, almost certainly soon. But for instance, you can add a right arrow or a left arrow with the emoji selector, and it will change the direction of various emoji. You'll notice though it has to be arrow with the emoji symbol, and again, or selector, and again, that tends to make it lay out correctly instead of regular text kind of black arrow or right arrow. Similarly, you'll be able to use color for non-human things like black cat. Okay. That brings me around to probably my favorite emoji sequence, which is the multi-person zero with joiner sequences. For example, this is a family sequence. Now, this looks like one character, and that does make sense. Look at it, it's in one little square. But it is 7 code points, 7 Unicode code points, and in UTF-8, it is 25 bytes long. The various other family emojis are created kind of the same way. There's the man joiner, woman joiner, girl, man joiner, boy. There's 25 recommended family combinations in the standard. Order here does matter. So in families, the order is man, woman, girl, boy. And you can have 0, 1, or 2 of each of them as long as there is at least one adult and one child, but they do have to be in that order. There are many more. People can be joined into families of 2 to 4 people. They can be holding hands. They can have a heart between them. They can be kissing. They can wrestle. They can stand together wearing bunny ears. Individual skin tone modifiers can be applied to each person when they hold hands, but not in any of the other combinations to handle the combinations of skin tone and gender. So 2 people holding hands is the one that you can kind of do everything with, right? You can have neutral. You can have a gender neutral, or you can have male or female, and I think they can be in either order, and they can have gender modifiers. They can't have hair difference. That requires 86 unique glyphs. And remember, each of those is made 9 times. As the spec notes, if we did the same thing for the family sequences, it would add 4,000 or more than 4,000 new glyphs. It would more than double the size of Emoji. So the spec technically supports it. It can happen. I mean, there is a syntax, but I doubt they'll be able to add it to the recommendation. It's just enormous. And again, here, order matters. Some multi-person groups do support multiple genders and some do not. For all of the non-family sequences that support multiple genders, women are before men. For families, however, man is before woman and girls are before boys. And of course, there's also a dedicated family emoji code point, that's separate from all of these. And this is the grammar of emoji. I don't care about localization. I just want English and emoji. But I love emoji. I really do. I love all the ways humans have invented to express themselves to each other. Emoji is messy and it's complicated, and sometimes it makes you want to scream, just like people. And like people, they also make you smile. And I hope you've learned something today. And even more, I hope I could make you smile a little bit too. So have a great conference.